Hello everyone, welcome to my class. Yes, this is the second class in sound wave. In this class, we will study in detail about infrasonic, ultrasonic waves, then what is meant by beat, Doppler effect, everything we will discuss in detail. This is the second continuous class of a sound waves. Okay everyone, welcome to my class. I am Sunita madam. Those who are not able to attend the live classes, please see the recorded class. When you are having free time, please watch my video. Please support my channel. Share to your friends, everyone. Make use of the videos. Okay. Those who are not applied for the ctet, first apply. This month 26 is the last date. Okay. Yes, let us discuss in detail about what is meant by a beat. What is beat? A wave not only travels in space, but it also propagates through time. Yes, in space, the wave not only travel in space, but it also propagates through time. Yes, propagation of waves, vibration of waves. Wave it will travel from one point to another point. That one only we will consider as a propagation of the wave. So, if two waves can produce interference by overlapping in space, they could also produce an interference pattern when they overlap in time. This phenomenon is called as a beats. How we will get the beat? When two waves of almost same frequency, okay, nearly same frequency. See here, for example, one is 100, another one is 120 hertz, almost same frequency, otherwise near frequency. Both the waves, when they will overlap, when they will mix each other, when they will interference by overlapping, they will even interfere also, then they will get overlap, then only you will listen a beat sound. There should also produce an interference pattern. They overlap in time. This phenomenon is called as a beat. Both also they will get overlap, almost same frequency. One is 100, another one is 120 hertz frequency. Both are also having same frequency. Both they will get overlap. The overlapped overlapped wave is nothing but a beat. Here you can observe both the waves, they will get overlap, then it will produce a beat. Then when does beat occurs? Beats occur when two waves of nearly same frequency overlap, create a new resultant wave. To understand this phenomena, let us consider an experiment. We will need two tuning fork of close frequency. One is 70 hertz, another one is 705 hertz. One is 700 hertz, another one is 705 hertz. Almost here you can observe the frequency. Two tuning fork, consider two tuning fork. It is producing a frequency of nearly equal frequency. One is 700 hertz, another one is 705 hertz. Then the difference in frequency is nothing but 5 hertz. Even the beat it will produce that is having the frequency of 5 hertz. Yes. Okay, one Consider a two tuning fork. One is producing 700 hertz, another one is 705 hertz. Both beat at a time. Both the frequency they will get overlap. Then it will produce a beat. That beat having the frequency of difference between the wave, that is 5 hertz frequency. That one you have to remember. That one only I wrote in terms of a point. I will read the point. Both the frequencies are almost identical, almost same. 700, 705. There is no significant difference in the audible frequency you hear when they play each other. When these tuning fork, when you hit against a metal, almost both they will make a equal sound. Even audible sound of both of them also it will be equal. Only small difference in the frequency is there. No, there is not that much difference. There is no large difference. Only small difference is there in the frequency. Then you can hear the audible frequency of a sound almost like same frequency with sound capacity, characteristic, everything it will be same. There is no significant difference in the audible frequency you hear when they play each other them individually, but when they play together these two frequency interfere with each other, then it will produce a beat. As they are very close to each other in terms of frequencies, their crest and crest interference produces a constructive interference. You have to remember here. Very important thing. When crest of one wave, then the crest of another wave. When both crest overlap, that interference we will call it as a constructive interference. When crest of one wave to the crest of another wave, both they will get overlap. That type of interference we will consider as a constructive interference. Then here what are the changes it will happen in constructive interference? Increase the amplitude of the wave. Amplitude of the wave it will get increase. Hence the loudness of the sound it will be increases. Therefore it will lead to the loudness, otherwise heaviness. Loudness of the voice it will be result because two waves of crest and crest interference it will happen. That type of interference we will call it as a constructive interference. Then here because of this one amplitude of the wave it will be increases. When amplitude is increases, loudness of the sound it will be increases. Very important point you have to remember. That's why I am repeating. When a crest trough meet the interference, like crest of one wave, trough of another wave, when they will get both they will get interference, produces will be destructive interference. Okay, what will happen? Destructive interference, they both will cancel out. The amplitude produced will be equal to 0. Why? The amplitude, both of the amplitude. Here crest trough it will become constructive interference. Destructive name itself it is indicating the amplitude it will become 0. Why amplitude it will become 0? One wave of the crest, another wave of the trough, opposite they are meeting. Therefore amplitude it will become 0. Hence loudness it will be reduces to 0. In which case the amplitude it will become 0 when crest of one wave to the trough of another wave. Once they will get overlap. Okay, then amplitude of the two waves it will become 0. Overlapping waves it will become 0. Therefore the loudness also it will become 0. The frequency at which the loudness increases decreases are known as beat. Beat frequency. What is the meaning of a beat? When two waves when they will get superimposed, otherwise once they will get overlap, interference, then it will produces a beat frequency. This beat frequency is equal to the difference between the two waves which is produced. Yes, already I told beat frequency is nothing but difference between the wave. This it will be 5 hertz. Difference between the two overlapping frequency. Two overlapping frequency. That is the frequency of a beat. The difference between the two frequency is nothing but frequency of the final beat. Here I mentioned here. See here, 5 hertz. We can find out the difference in two close frequencies by listening to their beats. The closer the two beats or the smaller the resultant frequency, eventually the beats would be disappear. See here, some beats they are very close, 5, 5, 5 hertz, 4 hertz. These two beats they are frequency, it will be very close to each other. Then here you can't differentiate the beats. Sometime even you will get 0 hertz of a beat. Understood? Beats, when you are having a large range of a beats, when you are having a large difference of beats, like one is 100 hertz, another one is like 20 hertz, you can observe here the large difference in the beats. Then only you can recognize the difference in frequency, difference in the sound, everything. When it is very clear, you are not able to recognize the beats as this case. Let us study next one. Piano tuners use this technique of beats and interference to tune piano wires finally. Yes, piano. Before they playing the piano, everything they will adjust, strings, everything. Okay, why they will do? They will tune. They pluck the wire, a tuning fork at the same time. Yes, they will pluck the wire, they will tune the fork. Then depending on the beats frequency, they will tighten and loosen the wire tension to increase and reduce the frequency. Even the wire, they will stretch, even they will tight the wire, even they will lose the wire, reduce the wire, because they have to adjust the frequency, thereby tuning the wire to the same frequency as the fork. Even the fork, which one they are making, that it will produce the sound, no, piano, that fork and also that wire frequency, both also they have to match. Eventually the beats vanish when the wire is perfectly in tune. Yes. Next, what is mean by beat frequency? The beat frequency is when two sound waves with different frequencies come across each other, then their amplitude get added, subtracted alternatively for a given time period. This leads to the growth of the sound to be louder or softer. I told, when you are having crust meat, truffed meat, then you will get a louder sound. When the sound waves, one of the wave of the crust, truffed meat, you will get a softer. Here in louder means amplitude is more. Already I explained everything. Soft means amplitude, it will be less. These are the beat frequency. One more diagram I indicated here. Okay, not able to see properly. Okay. This frequency is here, I mentioned here, 30 hertz. This is 32 hertz. Say almost same frequency. Next important application of sound waves is the Doppler effect. Very important application. Okay, this one definitely in the exam they will ask. Doppler effect. Doppler effect or Doppler shift is a phenomena that is observed whenever the source of wave is moving with respect to an observer. For example, an ambulance crossing you with its siren blaring is a common physical demonstration of the Doppler effect. Doppler effect here, assume here the ambulance, here the person A is standing in front of the ambulance, the person B is standing for backside of the ambulance. Here once you hear the siren, this ambulance, it will make the siren, then it will travel. Once this ambulance is approaching the person A, then he will listen the louder sound. Here the waves, they are very closer. Yes, the sound waves, they are very closer. These are the sound waves. Whether he will approach the receiver, he is the receiver. Whether he will approach, if he move towards the ambulance, otherwise ambulance is moving toward him. In both the case also, loudness of the ambulance siren, it will be increases, and also you can see the sound waves also, they will become thicker, very close to each other. This person B, he is far from the ambulance. Here you can see the sound waves, they are not, they are far from each other. Then here the intensity of sound, it will be less. Frequency, intensity, anything you can consider. Okay. I will explain the definition of a Doppler effect. Listen here. Doppler effect is an important phenomenon in various scientific disciplines, including planetary science. The Doppler effect or the Doppler shift describes the change in the frequency of any sound. It will indicate the change in frequency of any sound. Sound are light wave produced by a moving source with respect to an observer. Here, which one is the source, which one is the observer? This one is the source. Then here, this boy is the observer. This boy is also a observer. Here, what you have to remember, when this source and observer, when they are approaching each other, like this, when they are approaching each other, what will happen? The loudness of the sound, otherwise the frequency of the sound, the intensity of the sound, everything, it will get added up. If the person is moving far from the source, this person is moving, this source also it is moving, when they are in far, when they are in opposite direction, the intensity of the sound, otherwise the pitch of the sound, otherwise the sound waves, they will be far from each other. That is nothing but a Doppler effect. That is the two important case you have to remember. When the source and observer, when they are approaching, when they are in the approaching direction, both they are approaching each other, what will happen? Intensity, frequency of the sound waves, everything, it will increases. Even the sound waves, they will be very closer. When source and observer, when they are moving far from each other, frequency, intensity of sound, everything, it will become less. Even the sound waves also, they will be far from each other. That effect we will consider as a Doppler effect. Easy one. Doppler effect in physics is defined as the increase or decrease in the frequency of sound, light, other waves as the source, observer move towards or away from the each other. When they will approach each other, frequency and sound, everything, it will increases. Frequency, sound, pitch, everything increases. When they are moving far from each other, frequency, amplitude, then intensity of sound, everything, it will be decreases. That is nothing but a Doppler effect. Okay, one more example here. You can consider here, this car is moving in this direction, this girl also moving in this direction, both are approaching each other. Here intensity, frequency, amplitude, loudness, everything, it will be more. Here this boy is moving in this direction, this car is moving in this direction. Here the intensity, frequency, loudness of this car is making a sound, everything, it will get decreases. Okay. Doppler effect formula is given here, that one you have to remember. F, it will be equal to V plus or minus V naught divided by V plus or minus Vs into F. What is mean by F dash? Here F dash, observed frequency, otherwise observer frequency. F means actual frequency. V means velocity of sound waves. V naught means velocity of the observer. Vs means velocity of the source. That one you have to remember. Next, my last topic, infrasonic, ultrasonic sound waves and their uses. That one is very, very important. What is mean by infrasonic sound waves? The term infrasonic applied to sound refers to sound waves below the frequency of audible. Nominally includes anything under 20 Hertz. Below 20 Hertz. Under 20 Hertz means below 20 Hertz. Infrasonic sound waves. The frequency below 20 Hertz. Sound produced by earthquake. For example, infrasonic sound waves are earthquake, volcanic eruption, ocean waves, weather, lee waves, avalanche effect. This one you can study this one in transistor. Waterfalls, meteors, lightning, everything are the example of infrasonic sound waves. Then what is mean by ultrasonic? Infrasonic, you have to remember the frequency less than 20 Hertz. What is ultrasound? Sound waves with frequencies higher than the upper audible limit of human hearing are called ultrasound. The limit varies from person to person, but it is approximately 20 Hertz. A physical properties of ultrasounds are similar to normal audible sound. A type of scientific concept is used in many different fields such as navigation. What is the use of ultrasound? Navigation, medicine, imaging, cleaning, mixing, communication, testing. All this field we will use ultrasound. Even in nature, bats, porpoises use the particular technique for the location of prey, obstacles. In the following section, we will learn its application. Ultrasound. Okay. Human audible range approximately 20 Hertz to 20,000 Hertz. 1 minute. 1 minute I will take. Yes, ultrasound is above 20 Hertz we will consider. Above 20,000 Hertz you have to consider ultrasound. Okay, human audible range 20 Hertz to 20,000 Hertz. Where we will use ultrasound? Navigation, yes, navigation, medicine, imaging, cleaning, mixing, everything. Let us discuss in detail here. Ultrasound means the frequency above 20,000 Hertz. That one you have to remember. In the cleaning purpose, how we can use the ultrasound? Let us discuss here. In objects with parts are difficult to reach, for example, spiral tubes and electronic components. The process of ultrasonic cleaning is used. Here the object is dipped in a solution of suitable cleaning material and ultrasonic waves are passed into it. As a result of this, high frequency waves are generated that cause the dirt and grease to detach from the source. Here cleaning purpose we will use ultrasound. How we will use means we will dip on this cleaning instrument to some chemical cleaning material, the solution of dipped in a solution of cleaning material. What we will do, we will send ultrasonic waves. Then that ultrasonic waves are high frequency, more than 20,000 Hertz means more frequency only. Then you will pass high frequency waves. What will happen? It will remove dirt and also grease to detach from the surface. Yes. Then detection of cracks. Very big instruments, very big instrument, even small instruments where you can't reach, in that one to remove the cracks, to alter the cracks, otherwise to manage the cracks, what we will do, we will use this ultrasonic waves. Ultrasound is used to detect cracks in metallic components that are used in the construction of high-rise structure such as building and also bridge. In very big building and bridge, ultrasound. Okay. Okay, in bridges and also bridge bridge, if any cracks happens, if to correct that one, we will use the ultrasound. They generate, display an ultrasonic waveform that is interpreted by a trained operator, often with the aid of analysis software to locate the categorized flaws in a test piece. Here, what they will do, they will send high frequency ultrasonic waves. What they will do, they will detect the crack, and also even they will first they will detect the crack, even they will correct that one. Then high frequency sound waves reflect from the flaws in predictable ways, producing distinctive echo patterns. What they will do, they will reach the crack part. Once they will send the high frequency of ultrasound, what they will have, that waves, they will hit the crack part. Once again they will get bounce back, they will get reflected back. A trained operator identifies specific echo pattern corresponding to the echo response from good parts from representative flaws. The echo pattern from a test piece may then be compared to the pattern from these calibration standards to determine its condition. Later they can cure the cracks also. In detail, that much in detail no need to study, but they will send the high frequency of ultrasound. Then once that ultrasound, once they will hit the cracks, then you will listen the echo sounds. No, if that echo sound is not proper, then you can detect if it is not proper as the regular instrument, correct instrument, then because of the difference in the echo sound, then they can identify in this instrument this part is having the crack, this can be corrected. Echocardiography. In the process of echocardiography, the ultrasonic waves are produced form an image of heart using reflection detection of these waves from various parts. Echocardiography, this one based on the heart. To do heart surgery, echocardiography they will do. They will send ultrasounds. Okay, then if any blockage is there in the heart, if any organ is failed to function, everything you can detect using echocardiography. Ultrasonography. Medical ultrasound is a diagnostic imaging technique. Based on it, it is used for imaging of internal body structure such as muscles, joint, internal organs. Yes, when you will send ultrasound to your body, you can get the image of a particular body, whether it is a like kidney, liver, stomach, intestine, small intestine, then even all the type of a body organs, you will get the image. Then if anything is there, if any object, any cancer, any cells, any extra growth in the organ, anything, then you can easily identify with the image. Ultrasonic image are known as sonograms. In this process, pulses of ultrasound are sent into the tissue using a probe. The sound echoes of the tissue, where the different tissues reflect sound varying in degrees. These echoes are recorded and displayed in the image. Even you can hear some small babies, fetus we will call, early pregnancy, how they can you can listen the heartbeat of a small baby, 2-month baby, 2.5 month baby, you can hear the heartbeat. How it is possible? Because of the ultrasonography, you can hear the heartbeat of a small baby. With the help of the echo sound, you can hear. Sonar, already I explained. Sonar, sound navigation and ranging. It is a technique in which sound waves are used to navigate, detect, communicate under the surface of the water. These are the few important things today I explained. Doppler effect, echo, then infrasonic, ultrasonic, ultrasound, everything we discussed today. Okay, please watch both the theory class in sound waves. Then if I am free, I will solve one more, I will take one more MCQ question based on the same topic, sound waves. We will discuss few MCQ questions. Easily you can answer if you watched my the theory class. Otherwise you are not able to answer. Okay, thank you everyone. Thanks for watching my class. Okay, please watch the class properly, regularly. Well, when you are having the time, please watch my class. Support to my channel, support me. I need your support. Share my videos to your friends. Okay, thank you everyone. Take care, read well.